All right, with related rates, it's a lot like implicit differentiation. We just have to be careful with what variable we're integrating with respect to. They want us to find dx dt. They give us a lot of these knowns. So I'm going to go ahead and think, all right, if they want dx dt, the rate that this side length is changing as my rectangle is increasing in size, then I need the dx dt, I need the rate that x is changing. So I'm going to start with x squared plus y squared equals z squared. Then I can take the derivative of everything with respect to t. So the derivative of x squared is 2x dx dt. The derivative of y squared is 2y dy dt. And the derivative of z squared is 2z dz dt. At this point, I'm going to plug in things that I know. My x is 4. So I've got 2 times 4. My unknown is dx dt. My y is 3. My dy dt is this information here that I'm going to come back to. And then I'd have 2z. And again, if this, at this moment in time, if my x is 4, my y is 3, my z has to be a 3, 4, 5 triangle. So my z is going to be a 5, and dz dt is 1. Now they want dx dt. And we know that dx dt is 3 dy dt. And I need to plug in, I need to substitute in here for dy dt. So would you agree if dx dt is 3 times dy dt, I could divide out that 3, and 1/3 dx dt is equal to dy dt. Are you okay with that simple algebra? I divided through by that 3. Dividing by 3 is the same as multiplying by 1/3. So now instead of writing dy dt here, I'm going to do a substitution and say I've got 1/3 dx dt. Because they wanted us to find what dx dt is, so I'd rather have one variable in my problem. I'm going to simplify 2 times 4. I'm going to have 8 dx dt. And 6 divided by 3, I'm going to be left with 2 dx dt equals 10. This is coming out quite nicely. 8 dx dt and 2 dx dt would be 10 dx dt equals 10. Divide by that 10 and I'd get my dx dt equals 1. All right, we are talking about the radius of a sphere increasing. And they're telling us that the radius is increasing at a rate of, so dr dt is 0.3. At the instant when the surface area is 100 pi. What is the rate of increase in cubic inches per second of the volume? They want dv dt is what they want. Okay, well, the volume, as they told us, volume of our sphere is 4/3 pi r cubed. And if they want dv dt, I'm going to go ahead and take that derivative. 4/3 pi is just a constant. You could think about this as a function times a function and do product rule. But what's f prime going to be? The derivative of constant's just 0. So f prime times g would be 0. So we're left with g prime, which would be 3r squared dr dt times 4/3 pi, because we need to bring the f function with it. So my dv dt would simplify to b, my 3's would cancel, and I'd be left with 4 pi r squared dr dt. I think that's an interesting observation here. That's the derivative of volume, which is also equal to the surface area. So let's go ahead and plug in some things that we know. We've got 4 pi. We don't know the radius. I'm going to come back to that. But we do know that our dr dt is 0.3. So I'm going to go ahead and substitute that in. In order to find the radius, we're going to need to use the surface area information. We know that surface area is 4 pi r squared. And they said the surface area of the sphere is 100 pi. So I'm going to go ahead and set those equal to one another. I'm going to divide by 4 pi on both sides to get 25 equals r squared. Therefore, my radius is 5, and I can substitute that piece of information in. I'd have 5 squared is 25. 25 times 4 is 100 pi times 0.3 is going to get me 30 pi. Okay, so we've got this ladder sliding down a vertical wall. That would be a scary situation to be involved in. The ladder is 25 feet long. That's not changing. I'm going to put that in my picture. It's sliding down the wall at a constant rate of 3 feet per minute. So I'm going to say my dy dt is -3 because it's sliding down. When the top of the ladder is 7 feet from the wall, at the moment y is 7, what is the rate of change of the distance between the bottom of the ladder and the wall? So they want dx dt. So dx dt is what we want. All right, the equation that I would use is the Pythagorean Theorem, x squared plus y squared. In this case, that 25 is a constant, so I'm going to leave it. Let's go find that derivative with respect to time. The derivative of 25 squared, because it's a constant, will be 0. I'm going to plug in what I know. I do not know what x is. But at this moment in time, if my y is 7 and my hypotenuse or ladder length is 25, we could do the Pythagorean theorem with those knowns. And this is a Pythagorean triple. If we know that, it helps a lot. So we'd get x squared equals, I don't even know what 25 squared minus 49 is, but I do know that a 7, 24, 25 is a Pythagorean triple. So I know that that third side, x, is 24. dx dt is what we're looking for. My y at this moment in time is 7. My dy dt we said is -3. We now need to go solve for dx dt. I'm going to have 48 dx dt equals 7 times 2 is 14 times my 3 gets me 42. I'm going to take that -42 and add it over to be positive 42. I'm going to divide 42 by 48 and I'm going to get dx dt is 42 48ths. They're both divisible by 6, so we'd get 7/8 feet per minute that this ladder is sliding down the wall at that moment in time. Okay, they gave us the velocity. They gave us that first derivative of the velocity in meters per second of a type of wave. H is the depth. What is the rate of change in meters per second per meter, okay, of the velocity of the wave? They want what is the rate of change of the velocity. They want the derivative of velocity when the depth is 2 meters, when my h is 2. Okay, so if my velocity was 3 root h, or 3h to the 1/2, what would the derivative of that be? What would v prime be? Well, I'm going to bring my exponent out front, so it would be 3/2 h to the -1/2, which is the same as 3 over 2 root h. They wanted this second derivative the moment when h is 2. So when I plug that in, I'd have 3 over 2 root 2. And I got C. All right. Now we've got our triangle. And it says if theta increases at a constant rate of 3 radians per minute. So d theta dt is increasing. Okay. At what rate is x increasing? We want dx dt when x is 3. The moment that x is 3, that would make this a 3, 4, 5 triangle. All right, we want dx dt. So what kind of derivative could I take given that they told me d theta dt? They gave us that value. So I'm going to involve theta instead of doing the Pythagorean theorem. They gave us an x and a 5, so that is opposite and hypotenuse of my angle. So I'm going to say the sine of my angle equals x over 5. Notice that I didn't say 3 over 5 because that 3 is just a certain moment in time. And this function is, this function will always stay true because x is a variable. All right, if I want dx dt, I know I've got to take a derivative of this. The derivative of sine, if I were to take the derivative of this, the derivative of sine is cosine, leave the angle, times the derivative of the angle, d theta dt. And the derivative of x divided by 5, if you think about it that way, that would be the quotient rule. But if you think about it as 1/5 x, the derivative of 1/5 x is 1/5. The derivative of that x is dx dt, and that's what we're looking for. Let's go plug in some knowns. The cosine of theta at this moment of time, the cosine of theta is adjacent over hypotenuse, so 4 over 5. And I've got, so 4 over 5 times d theta dt, which is 3, equals 1/5 dx dt. So we'd have 12/5, because that's really over 1, equals a 1/5 dx dt. This is looking great because When I divide by 1/5, that's really the same as multiplying by 5 over 1. And these are going to cancel out. These cancel out, and I'm left with 12 equals dx dt, and that is answer E. All right, on 21, let's go ahead and write out what we know. Oh, we've got an ugly equation. W equals x squared y. And it says x is decreasing. So decreasing at a rate of 1. So dx dt is -1. I'm going to give myself some more room. Y is increasing at a rate. So dy dt is 1. Oh, no. Y is increasing at a rate of 4. And at what rate is w changing? So they want dw dt when x is 6 and y is 20. Okay, that means we got to go take a derivative of the formula that they gave us, the equation they gave us. The derivative of w is dw dt. These are two different functions being multiplied together. So I'm going to go ahead and move my dw dt, give myself some more room. So we've got dw dt equals, we're going to have to do product rule. The derivative of x squared is 2x dx dt times my y, that's f prime times g, plus g prime dy dt times f, which is x squared. Guys, it's a lot, but we can just plug in from now. We're looking for dw dt. dw dt is already by itself. Great. So that's going to equal 2 x's. X is 6 right now. dx dt was -1. My y was 20. My dy dt is 4. And my x squared, my x was 6, and we got to square it. Okay, it's multiple choice. So we've got a -12 times 20, which would be -240. 36 times 2 would be 72, so 36 times 4 would be 144. -240 plus 144 is -96. All right, this question is saved the best for last. It's difficult for sure. So it says we've got a triangle in the xy plane. Two vertices are at 1, 0. There's a vertex 2, 3, 4, 5, and at 5, 0. And the third vertex is on this graph, which without a calculator, we probably don't know what it looks like. But I'm here to tell you it doesn't matter what it looks like. So let's say we think our function looks something like this. And again, it doesn't matter. That third vertex is going to be somewhere on it. So my triangle could look like this. But let's say someone had a triangle that looks like this. That's totally fine. It doesn't matter. And here's why. Don't you agree to find the area of a triangle? The area of a triangle is always 1/2 base times height. My base, no matter what, is going to be 1, 2, 3, 4. So I can substitute that in, that the area of my triangle is going to be 1/2 times my base. And again, that height is this distance, which is just the value, it's just my function. Because again, no matter where I drew, this is again the base, they made it. If I thought that my function looked like this, it doesn't matter. That base is always going to be 4, and that height is going to be whatever the function is at that x value. So I'm going to go ahead and plug in that my function is ln of 2x minus 1/2. Well, I'm going to have to give myself some room. X plus 5. So this is the area of my triangle, okay? I'm going to simplify this a little bit before I do any calculus. So the area would be 1/2 of 4, which is 2. And I'd have 2 times the natural log of 2x minus 2 times my -1/2 would just be minus an x plus a 10. Okay, if they want the maximum area, maximums happen when my function, goes from increasing to decreasing, or the slope goes from positive to negative. So I've got to go find the slope, or a prime, of my area. The derivative of 2 times the natural log of 2x would be 2 times 1 over 2x times the derivative of 2x, which is 2. The derivative of -x would be -1. So if I were to clean this up a little bit, we get the area, the derivative of the area, the rate that the area is changing is 2 over x minus 1. So in order to find a maximum, again, that's where my slope goes from positive to negative, or my slope goes from positive 0 to negative, or positive undefined if I were to have a cusp or a corner. And in this case, we are going to have an undefined slope. At what value will this slope be undefined? And this slope would be undefined if x was 0, because we cannot divide by 0. So my slope is undefined at x is 0. When is my slope equal to 0? Well, that'd be when 2 over x equals 1, or 2 equals x. So these are my two critical numbers that I've got to evaluate. The question asks, what is the maximum area? Well, would you agree, since my triangle starts at 1 to 5, 0 is not in the domain of this function. So 0 I can disregard. Because I only had one other critical number, we're going to have our maximum when x is 2. I could prove this with a sign chart, but for the sake of time, they ask, what is the maximum area? Well, if the area is happening when x is 2, we're going to go ahead and plug 2 back into our area formula, 2 in for x. So I know that the area is equal to 2, and actually, since I've already simplified my area formula here, I'm going to go ahead and plug it in right there. X is 2, so I'd have 2 times the natural log of 2 times 2, which is 4, minus my x of 2 plus 10, giving me a final answer of 2 natural log of 4 plus 8, answer C.